Okay, so today we are starting Unit 3, which is called Projectile Motion. This unit is it falls under the umbrella of mechanics, and basically in this unit we're going to be expanding upon our understanding of motion by looking at a situation where you have constant velocity and constant acceleration at the same time. Okay, and so we're just going to keep building on the skills that we developed in the last unit. Some of the concepts and skills that you learn in this unit are going to be used throughout the school year, so please make sure that you're taking really good notes, asking questions as needed. We're going to be learning some new math skills before we get back to physics. And so before we actually get into projectile motion itself, we're going to focus on two things basically. We're going to review some very basic trig, and then we're going to look at vector components and finding components of vectors. Okay, and we'll do that later on. Today we're just going to focus on reviewing trig. Now, just to remind you, we talked in the past about the difference between a scalar and a vector. And so a scalar is a physical quantity which has only magnitude, whereas a vector is a physical quantity which has both magnitude and direction. Okay, and again, when I say magnitude, I mean amount. I mean the number part of a physical quantity. And so examples of scalars, and again we've talked about this before, but examples of scalars could include mass, or time, or temperature, or volume. Speed is a scalar. Distance is a scalar. There's way more scalars and vectors in physics. Okay, so those are some examples of scalars. Vectors, on the other hand, there's not a ton of vectors. Well, I shouldn't say that, but there's definitely more scalars than vectors. But there's not a ton of vectors that we've seen so far this year. Okay, so basically the only vectors we've seen are displacement, velocity, and acceleration. And we'll see a couple more this year. We'll see in the next unit after this when we talk about force. Force is also a vector. And then we'll talk about momentum next semester. And those are basically going to be the only vectors that we're concerned about this year. Now, vectors, as we'll see in this unit, because they have direction, mathematically handling vectors is actually much more complicated than handling scalars. Okay, and so we'll kind of ease our way into that, starting with some trig review today. Okay, so pause there if you need to finish adding that to your notes. Okay, so talked before about how dealing with vectors is much more complicated than dealing with scalars. Basically, we're going to be focusing on reviewing trig today. Trigonometry is a branch of math, as we'll see, and we basically need those basic skills in order to talk about vector components, which you need to basically do problems involving vectors. Okay, and so we're just going to kind of ease into it. Vectors used to be part of the IB math curriculum. They no longer are. So I will change this to used to be a part of the IB math curriculum. I believe they might be part of the pre-calculus curriculum, but I'm not completely sure. So if you're in either of those classes, it's possible you might hear about vectors, but basically this is something that is really just math, and we'll be seeing how you can apply it to physics here in a few days. Okay, so let's start off with some basic trig review. So trigonometry is the branch of math that deals with triangles typically. Okay, normally right triangles. That means a triangle that has a 90-degree angle. And there's three basic trig relations that you need to know about. Okay, there's actually 6, but normally in high school you only learn about the first 3. Okay, and so those basic trig relations are sine, cosine, and tangent. And hopefully those sound familiar to you. Okay, now sine is often abbreviated as sin. Okay, so on your calculator, when you see sin, that is the abbreviation for sine. Cosine is typically abbreviated as cos, and then tangent is typically abbreviated as tan. So when you see these buttons on a scientific calculator, that's what that represents: sine, cosine, and tangent. Now these three basic trig relations relate back to a right triangle, like I said before. And so let me draw a right triangle. Okay, so typically when dealing with a right triangle, you know, of course, one side has a 90-degree angle, and you're typically given at least one angle or asked to find one angle. And so let's say we have this angle down here in the bottom left, and let's say this angle is theta. Okay, so this is the Greek letter theta. Just like in algebra, when you use x to represent an unknown number, it's very common in math and physics to use theta to indicate an unknown angle. You don't have to use theta. You could call it x if you wanted to, but that's just what's typically used, is theta. And if you need more than one angle, then we might see some other Greek letters just for fun. So let's say we have this kind of generic right triangle. The side opposite to that angle is what we call the opposite side. A very imaginative. I don't think that's a word. Okay, so we have the opposite side, and then we have this side down here, which is called the adjacent side. All right, you shouldn't really be confusing the opposite and adjacent side, but if you imagine, starting at the angle and going straight out from that angle, the side that you hit first is the opposite side, and then the other side is the adjacent side. And then, of course, the side opposite to the right angle is what's called the hypotenuse. Hypotenuse. All right, now, you might have heard of something called SOHCAHTOA, and SO, S-O-H, CA, C-A-H, TOA, T-O-A, is basically a mnemonic to remember the trig relations. Okay, so here's how this works. Sine, let's say sine theta, given our right triangle, is equal to the ratio of the opposite side over the hypotenuse. Cosine, CA, C-A-H, is the adjacent side, that's what the A is for, adjacent, over the hypotenuse. I apologize for my bad handwriting. And then tangent, TOA, is the ratio of the opposite side to the adjacent side. And hopefully you're familiar with this from your geometry class. That's what you normally learn about these things. Okay, so you have SOHCAHTOA. Okay, so sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent is opposite over adjacent. So notice each of these trig relations is basically representative of a ratio of two values on a right triangle. Okay, we're going to be using trig a lot over the next couple months, and so I expect you to become very, very, very familiar with trig calculations. The problems we're going to be seeing today are very basic, and so if you need to brush up on your trig skills, that's fine, but you need to make sure that you're doing enough practice so that you become very, very familiar with these three trig relations. Also, always make sure that your calculator is in degree mode. If you have a scientific calculator, it should have a button that says mode. That should let you turn it into degree mode and not radian mode, which is the other common angle. If you don't know what a radian is, that's fine. We'll talk about that later this year. For now, we're going to be doing everything in degree mode, and so it's very important that your calculator is in degree mode, otherwise you might get the wrong answers. Okay, so make sure you have this in your notes, and we're going to start looking at some examples. Okay, so I'm going to erase this. Okay, and the only other thing, I think I've talked about everything on here before. The only other thing you might want to make sure that you add to your notes is that last bullet point here. To find an unknown angle, you must use the inverse trig function. Okay, and so let me explain what that means. So normally, well, I shouldn't say normally, but oftentimes you know what theta is. You know what angle it is you're talking about. So let's say you have sine theta is equal to the opposite side over the hypotenuse. Okay, normally you know what theta is, but let's say you don't know what theta is, and let's say you're solving for theta. Now, the basic tenet of algebra is if you want to solve for something, then basically you need to know how to undo different mathematical operations. So for example, if x is being multiplied by 5, then you would divide both sides of the equation by 5. If x is being squared, then you would take the square root of both sides. The opposite of sine is what's called inverse sine. Okay, and the way you write that is with a negative exponent. Okay, so inverse sine, if you take the inverse sine of sine theta, that basically gives you theta. Okay, and there's also an inverse cosine and an inverse tangent, and you should be able to find those buttons on your calculator as well. And so you would only use inverse trig functions in situations where you're trying to find an unknown angle. Okay, so just something to keep in mind. Alright, so let's do some examples, and then we'll finish up this video. Okay, so example 1. We're given a right triangle. Example 1 says find the lengths of side B and C in the diagram shown to the right. So notice we're given the angle in the bottom right, and we're asked to find side lengths B and C. So let's start with finding side length B. Now, the way you do this is, like any physics problem, you start by identifying what you have. Now, we have theta, clearly, is 25 degrees. That's the only angle that we're given. And we also have this side down here, okay, this 8 meters. Now, remember, there's only 3 sides on a right triangle relative to an angle. The opposite side, the adjacent side, and the hypotenuse. Okay, in this case, relative to this angle, this 8 meters is the adjacent side because the opposite side is B and the hypotenuse is C. So I would say that that 8 meters, I would label that as the adjacent side. And to find B, which is the opposite side, let's say opposite side is my unknown, I need to find the trig function that has opposite and adjacent. So I think so, ka, toa. Which trig function has the opposite and adjacent sides in it? Well, that would be tangent. Okay, so I would write down tangent of 25 degrees. You always have to have an angle inside of a trig function. That's just kind of how that works. Okay, and so tangent of 25 degrees is equal to, remember, toa, that is the ratio of the opposite to adjacent side. So the opposite side is B, and the adjacent side is 8. And if I want B by itself, then I need to multiply both sides by 8. And so I get B equals 8 times tan 25 degrees. Now again, you always have to have something inside of a trig function. You can't just have tangent. Okay, tangent by itself is kind of like having an empty square root. You can't just have a square root sign with nothing underneath it. It has to be acting on something. Okay, so when you have sine or cosine or tangent, whatever's inside there has to be an angle. Okay, so just keep that in mind. All right, because sometimes people like to put the 8 inside the tangent, but you can't do that because this 8 is a side length. This 25 degrees is an angle. Okay, you can only have angles inside trig functions. So we want to do 8 times tangent of 25 degrees, and all you have to do is plug that into your calculator. And your calculator, as long as it's in degree mode, will give you the correct value, which should be 3.73. In this case, the unit is meters. Now, what if I want to find side C? Well, at this point, I have a couple options. I could use the Pythagorean theorem, because I know that 8 squared plus 3.73 squared should equal c squared. Okay, that's just the Pythagorean theorem. Or I could use another trig function, because now I want to find the hypotenuse. That is my unknown. So I would pick one of these trig functions that has hypotenuse in it. Let's say sine. And I would write down that sine of 25 degrees is equal to, let's see, sine is so opposite over hypotenuse. The opposite side I just found is 3.73. Divide by the hypotenuse, which actually I guess is c. And now if I want to get c by itself, I have to do a little bit of rearranging, but it's not that bad. What I would do is I would multiply both sides by c to get that on the top. And then I would divide both sides by sine of 25 degrees. And I would get c is equal to 3.73 divided by sine of 25 degrees. Now, if you plug that into your calculator, 3.73 divided by sine of 25 degrees, you will get approximately 8.83 meters. Okay, so that is side length C. Now, just a couple things to point out. If you don't know this already, it's just kind of a basic trig fact about triangles. The hypotenuse is always the longest side in the triangle. So if you were to do this calculation, and let's say you get 5, you know you messed up, right? Because 5 is obviously less than 8, and that's that's wrong. The hypotenuse is always the longest angle in a right triangle. The second thing is you might be wondering, why did I use sine? Why did I not use cosine? Okay, because cosine also has the hypotenuse in it. And to tell you the truth, I could have used cosine, and I would have got the exact same answer. In fact, I encourage you to check that for yourself and try to solve for side length c using cosine, and you'll get about the same answer. Now, I say about because remember that 3.73 was a rounded number, and so it might not be exactly the same, but it should be very, very close. Okay, so pause there if you need to look at that some more. Alright, so I'm going to erase this. Hopefully this is just a review and that you learned this in your past geometry classes. Hopefully you're not seeing this for the first time. But let's do a few more examples. Okay, so example 2 says, find the length of side x in the diagram shown to the right and determine the complementary angle in this diagram. Alright, so first things first, let's see what we are given in this triangle. So we have theta equals 60 degrees. Just to do the second question first, remember the complementary angle is basically talking about the other angle, whereby theta, this angle that we're given, and then this angle down here, which I don't know, I guess I should call it a name. I'll call it, let's say, beta. It looks like a fancy little B, but that's just a Greek letter. It's beta. It's like a bee with a tail. So let's say this angle down here is beta. Because of what I learned in, basic geometry, I know that all the sides in a triangle have to add up to 180. Okay, in a right triangle, this side is 90 degrees, which means that the other 90 degrees has to be made up by the two remaining angles. In other words, theta plus beta, or it doesn't matter what you call the two angles, but these two angles right here added together always have to give you 90 degrees. And so when I say determine the complementary angle, I'm basically talking about this unknown angle down here. Now, hopefully, that's very easy for you to answer because this is actually a 30, 60, 90 right triangle. This is a common triangle. And so hopefully you notice right away that this angle is 30 degrees. You could also just ask yourself, what plus 60 would give me 90? Okay, and so that would be 30. So let's get back to the first question. We're actually given this angle up here. We're asked to find the side length of x, which is adjacent to the 60 degree. We're given the hypotenuse, and so because we have the hypotenuse, okay, that's 13 centimeters, and we want to find the adjacent side, that's our unknown, we're going to use a trig relation that has adjacent and hypotenuse. Okay, so that would be, so cosine is adjacent over hypotenuse. So cosine of 60 degrees is equal to adjacent, which is my x, divided by 13, which is my hypotenuse. To get x by itself, I would multiply both sides by 13. I get x equals 13 times cosine of 60 degrees, which I believe should be 7.5 centimeters. Let me make a small correction there, sorry, 6.5 centimeters. All right, now that's the answer to the question, so we're done with example 2. You might be wondering at this point why not use the 30 degrees since we found that first? Okay, well, we could have found the 30 degrees, and again, you'd get the same thing. But if we use beta as 30 degrees, then we would be solving for the opposite side rather than the adjacent side. And so we easily could have done that. Okay, let me just show you. I'm going to erase what's down here. What we could have done in this problem, and of course we would get the exact same answer, is we could have said sine of 30 degrees is equal to, remember sine is opposite over hypotenuse, so that's x over 13. And so x, to get x by itself, you would multiply by 13 on both sides. X would be 13 sine 30 degrees, and if you plug that into the calculator, you'll see that is also 6.5 centimeters. Okay, and so it has to work both ways. Okay, so that is example 2. Pause it there if you need to look at that some more. All right, and we'll just do part of one more example just really quickly. I do want you to appreciate that everything we're doing right now is what I would consider basic math skills. This should be a review of math that you learned in geometry. The problems that we're doing now are very, very simple. Okay, at least they should be very simple, and you need to get to the point to where we can solve these types of problems in 30 seconds or less. Okay, if you're not there now, that's fine. You've got lots of chances to practice on your practice worksheet, but you need to be comfortable enough with trig, basic trig, to be able to solve these problems in 30 seconds or less. Okay, so for example, let's say I want to solve this problem. It says determine the missing angle in the triangle shown to the right. Now remember, when you're solving for an unknown angle, you're going to have to use an inverse trig function. Here they call it x rather than theta, which is fine. It doesn't matter what you call it. Identify your givens. Here we have the adjacent side to x, and of course we have the hypotenuse. So we need to use a trig function that has adjacent and hypotenuse in it, and that would be cosine. Cosine of x, I don't know what x is, but cosine of x is equal to 16. That's the adjacent side, divided by 25. Now, x is inside the cosine, so I need to get it out by doing the inverse cosine function. So what I'm going to do is I'm going to do the inverse cosine, but if I do it to one side, I need to do it to the other side as well. Inverse cosine of cosine cancels out. On the left, I'm left with x. On the right, I have the inverse cosine of 16 divided by 25. And so what you would do is on your calculator, you would do the inverse cosine. You would look, usually you have to press like second and then cosine or something like that. So it just kind of depends on the calculator that you have. But inverse cosine, 16 divided by 25. And if you hit enter, you should get an angle of 50.2 degrees. Okay, so just a real simple example there, finding an unknown angle. Okay, remember, anytime you're finding an unknown angle, you have to use an inverse trig function. And again, I can't stress this enough, when you're dealing with trig relations, the only things that can go inside trig relations, like sine, cosine, or tangent, are angles. Inverse trig functions are not angles, like 16 over 25, that's just a ratio. But for cosine or sine or tangent, the x has to be either an angle in degrees or an angle in radians. Alright, so we did 3 examples now. You've got plenty of practice on your practice worksheets, and you can check your answers as you go. Please, please, please make sure that your calculator is in degree mode before you start working on these assignments. As always, please let me know if you have any questions, and I'll see you guys in the next video.